Hey everybody, my name is Tam N. I'm a math tutor here at Chegg, and today I'm going to be talking about factorials. Alright, so a factorial is represented by an exclamation mark. You might have seen it before. And what the exclamation mark means, it means to take that number factorial. So to do that, you take that number, you multiply it by the number minus 1, and then that number minus 1, and then that number minus 1. So in the end, if you start with the number n, you get that n factorial is equal to n times n minus 1 times n minus 2, all the way until you reach 1. Okay? So let's take a look at the example below. We have 6 factorial. So we get 6 times 5 times 4 times 3 times 2 times 1, all the way down, right? You multiply them all up and you get 720. So it's a pretty straightforward process. So let's try to find, just 3 factorial. And that'll just be 3 times 2 times 1. And that would become 6. Alright, and factorials are used a lot, especially in combinatorics. Let's say I'd want to find different combinations of arranging things. That comes a lot in factorials. Let's say I have a red ball, or a red ball, a blue ball, and an orange ball, right? And I want to see how many ways can I arrange these balls. And so here's one way. We have blue ball first, red ball second, and orange ball third, right? That's way number 1. Alright, and then I want to find another way. I'm going to switch red and orange this time. So red's going to be here. Orange is going to be here. Alright. Now, let's say I want to switch red and blue on the original. So blue's going to be in the middle this time, and red's going to be first. That's 3 ways. And we want to find all the ways, alright? So trust me, we're almost done. It won't take that long. Let's say I want to switch orange and blue now in the original. Alright, you might see where this is going already. In the end, we're going to have 6 combinations, 6 different ways to do it. And starting the original, I want blue in the middle again. This time orange is going to be first, red's going to be last. And then the last way to do it is have red first, orange in the middle, and blue last. Alright, so these are all the different ways that you can arrange these 3 balls, right? There's no other ways, these are all of them. If you notice, we have 3 balls, and the number of combinations we can make, it's going to be 3 factorial, that's 6, right? So that's a neat way to find out how many combinations. And I say combinations because it's easier to understand, but technically this is what we call a permutation, because the order matters. You can look up other videos on that, but for now I'm just going to call it combinations because it's easier to understand. And if you do understand already, I should be saying permutation. Okay, so what this tells us here is that if you have an n number of elements, there's going to be an n factorial amount of ways to order these elements. Alright, so let's take look at another interesting property of factorials. Alright, so we know 3 factorial is equal to 6. 2 factorial is going to equal to 2 times 1, which is 2. 1 factorial is going to equal to 1. Let's say I want to take 0 factorial. Right? And you would think, right, anyone would logically think that 0 factorial is 0. However, that's not true. 0 factorial is 1. And that's just a fact you kind of have to accept. There's a few things you can do to convince yourself that 0 factorial is in fact 1. For example, let's say I have one red ball, right? I want to find out how many ways I can arrange this red ball. So we know earlier, by what we did earlier, that the answer is going to be 1 factorial. That's going to be one way to arrange the ball. And let's say I have a set of 0 balls, right? I have no balls at all. And I want to find how many ways can I arrange my set of nothing. Well, the answer is going to be one way. There's only one way you can arrange nothing, and that's nothing. Alright, another way you can prove to yourself that 0 factorial is 1. We can say, for example, that 3 factorial is equal to 4 factorial over 4. Right? Because then we get 4 times 3 times 2 times 1. Whoops. Put it all over 4. Well, the 4's cancel out. You get 3 times 2 times 1, which is just 3 factorial. So if we do 1 factorial, we get 2 factorial over 2, which is 2 times 1 over 2. It cancels out to 1. Let's do 0 factorial. Using the same pattern, we have 1 factorial over 1, which is equal to just 1. Alright, and those are just some things you can do to convince yourself that I'm not lying to you, that 0 factorial is 1. Alright, and that's all there is to factorials. They're very easy to find. Some interesting properties. I told you that 0 factorial is 1. And also factorials are very rapidly growing. They grow faster than exponential functions, in fact. So if you have a factorial, it's going to get... it's probably going to be a very big calculation if the number's bigger than, say, 10 or so. Right, and that was a lesson on factorials. My name is Tam N, and hope to see you guys next time.